Hey, eighth grade, how are you? I am here to explain what you are going to be working on for the next 3 science classes that you have. And we are working on rocket stability, right? So if we go into your classwork, and yes, it's rocket science experiments and data, you should have experiment number 3, rocket stability, right? So this is the 3rd experiment we're doing. So we've done egg drop, right? We've done an experiment to figure out how to pad an egg and how the parachute should work. We've done amount of fuel. So what is the ideal amount of fuel to put in your rocket for the maximum height? Now we're on to how to make a stable flight path. And what I mean by stable flight path, it's going up as straight as possible and it coming down as straight as possible. Because you might have remembered from our fuel experiment, some of them when they launched, it was windy and it went sideways. A lot of times when they came back down, the bottle spun, right? And it landed pretty far away from the launch point. So there are 2 documents attached to this. One is a sheet that we'll use to record data for when we launch. So this is another test launch that is going to happen when I'm back. You don't need this yet. What you need is experiment number 3, rocket stability. So right here. So I'm going to open that up. We're going to go through it together. So again, this is about stability. This is about creating a stable flight path, right? So your problem, right, is launch a rocket so that it flies as high as possible while returning as close as possible to the launch site. So I have a picture to demonstrate this. Right? So I want this rocket, right? So here we are on the launch site. We pump the air and we go 3, 2, 1, and it goes right, and it goes up and then back down. So what I want is for this rocket to go as high as possible while returning as close as possible to the launch site, right? So I'm looking for maximum height and minimum distance, right? So there's going to be 2 things we measure. We're going to measure and calculate the height, and then we're also going to measure how far it lands. So as high as possible while staying as close to the launch site as we can, right? And this is going to be important because the more stable your rocket is, the higher it's going to go, right? And the better flight path, the closest it comes back down to the launch site. So the more stable up and straight down, right, your rocket is, the more likely that egg's going to land safely on the ground. So what we're not going to do right now is get into any of the physics of why this works, of what rocket stability is. We will do that, not right now. What we're going to do is figure out, right, you're going to have a 1-liter bottle again. You want to figure out what are you going to add to that bottle to give it a stable flight path, right? So the first thing you're going to do is make a plan, right? And what I would recommend doing is go ahead, Google, research images of rockets, NASA rockets, model rockets, any kind of rocket. Have a look at them, right? Then based on that, plan out what you're going to build, right? It's going to be a well-labeled sketch, just like in the egg drop. This should look pretty familiar, actually. I also want you to think about here the types of materials you want to use. Is it cardboard? Is it paper? Is it aluminum foil? Do you want to 3D print something? So the material choice will matter, right? So plan out what you're going to do. Make sure you label it well. You and your partner can definitely have the same sketch. Put it in here. Okay? Then you're going to build, right? You're basically going to have 2.5 classes to do this, right? The quality of your build matters. Right? If you, let's say I'm done talking, you get started and somehow you make your rocket and you're done by the end of this class period, it's bad. That's not good enough, right? I'm giving you like 3 class periods, 2.5 by the time I'm done talking, to build this because quality matters. The better you make your rocket, the better it's going to fly, right? So you should be measuring things. Things should be exact. You should take your time taping and gluing. However you're putting the things on this bottle, right? Take your time, make it well, cut it out well, measure it, do a good job. I'm giving you this time, so I'm looking for some high quality builds here. I'm not looking for throw it all together. Blah, 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 blah. It's done. That's not what I want, right? High quality builds, right? So once you're done building, right, and again, you have three class periods to get this built, right? Don't rush it. Even after, don't rush it. Take your time, make it well. Then you're going to take a picture of it, right? And you're going to annotate a photo of your build, right? So you can do that in two ways. You can put that photo into Google Drawing and have Google Drawing, just label it. Or you can just put your photo in here and then write a couple sentences that describes your rocket, right? And we do this because a lot of times when you're building, your plan, what you actually build is a little different from the plan. And then the last thing you need to do is fill your rocket with 500 milliliters of water. So we're not worried about fuel, right? We want the same amount of water for everybody. Same amount of water, because we want to test the design of like what you are putting on your rocket. We don't want to test fuel. So please use a funnel and a graduated cylinder, right? And fill it up. This is the last thing you should do, 500 milliliters of water, okay? Make sure the cap's on tight so it doesn't leak, right? And then you're going to put it in your class bin, and I'll point out where those are in a moment. All of this, data, test, evaluate, we can't do that until after we launch, right? Because we don't know how high it went or the distance. So don't worry about this. We'll do this with me. We're going to launch when I get back, right? And then we'll fill this out. So what you need to get done is the plan, the prototype, and filling your rocket with 500 milliliters of water. Okay. Now I want to go over materials, where materials are, clean up, things like that. Okay, materials. So the first thing you and your partner need to do is come in this bin and grab a 1 liter bottle, right? Out of this bin right here. Please note that this is the top of your rocket and this is the bottom of your rocket, right? This is the part that it attaches to our rocket launcher, right? And this is the top of the rocket. When you are done at the end of class building your rocket, working on your rocket, you want to put it in one of these 3 bins right here. So 8.1 has a bin, 8.2 has a bin, and 8.3 has a bin. Right. Good materials to use. So again, anything in here is basically fair game. I'm going to say you cannot use the toolbox while I'm here. Okay, so that is off limits. One thing that's new that I want to point out are these cones. These might be helpful for you to use if you want to. And then, of course, we have cardboard. If you need to use any cardboard, it is here in this second cabinet. And then we have 2-liter bottles if you want to use 2-liter bottles. I'm going to say you cannot use the foam cutter while I am not here. So no, nothing from in here, no tools. Anything here is a yes. And then cardboard and 2-liter bottles are also a yes. You might want some thicker paper to use. I have cardstock paper. Here, let me go back so you can see where this is. Right here on this shelf, you feel free to use any of this cardstock paper that you want. We have white and colored. They're the same width, so that is totally fine. And then if we come to this side of the lab, we have all of our normal tools. There's rulers here, tape. We've got regular Scotch tape. We've got painter's tape. We've got duct tape. We've got electrical tape. We got colored tape. Sorry, I'm not doing a good job of keeping this in frame. Lots of different types of tape. Plastic bags if you need them here. Glue guns, glue sticks, regular glue here. Staplers if you need to staple anything together. live in here. Let's see, popsicle sticks, if you need that, are in here. Straws, I have some straws here if you want to use those for any reason. I have regular paper, scratch paper, printer paper. That's gross. Then just kind of basic, not cardstock, but construction paper here as well. Scissors, so this is where, you know, you're going to be doing the majority of your cutting. These are the cardboard scissors that work excellent for the cardboard, and then regular scissors for any paper that you might have. Not sure if you really need anything from this bin. This is just like wires and motors. Oh, if you wanted to use, we do have parchment paper, saran wrap. There's a little bit of aluminum foil here. I want to show you, right down there, there's aluminum foil. I want to show you where more aluminum foil is in a minute in case you want to use that. And then over here we have our string and things like that. So let me walk you back over here. Walking through the lab. Here is a big thing of aluminum, of aluminum foil. So if you need a lot of aluminum foil, it's here. Please be careful. This is sharp on this, on this edge right here. This is, sorry, one more thing just to point out to you if you need it. Paper bags are under here if you feel like you need a paper bag for any reason. So that's right by where my desk is. And I do have duct tape in this bin right here. Okay, I think that kind of points out all the materials that you can use.